Okay, so here what we have is an alternative definition for the derivative at that point. This is like the one we did in the previous video, except they've changed what they called the variable, but this still works. So let me just kind of point something out. In this case, scrolling up, right? In this case, what we called the variable was this, like the second x value. Okay, and then as that gets, moves closer and closer to a, what we saw was that this secant line starts to approach the slope of what we're calling the tangent line, right? We can do that same thing here. We can just relabel what we're calling the variable. So in this case, the variable is the change. This distance right here is what we're calling the variable. That's h. This is still the place where we want the slope. And this time, as this point moves towards a, essentially what we're saying is that h is getting smaller, right? H is just this horizontal distance, all right? I mean, another way to think of it is if you're really tied to the slope concept, like the slope definition, just know that when I subtract x values, a plus h minus a, the a's cancel, and I am left with the h down here, okay? So it's an alternative definition. It also works, and we're going to see how it works. It turns out to have more use in the long run than the other one, which is why we're gonna use it. Okay, so it's still a limit. It's a limit of slopes, and let's try using it here. So this says find the slope of the tangent line to the graph of x squared plus x at x equals 1 analytically by using the definition of the derivative. We already did this. It's 3, right? Go look above and see this example here. We know it's 3. But let's go and use this other definition. So the way this definition will work is I'm going to say f prime of my a is still a 1. It's the limit as h goes to 0. So that's different, right? It's not x goes to the number. It's h goes to 0 always. I'll kind of half plug it in. This is f of 1 plus h minus f of 1. Okay, remember my a is a 1 divided by h. So students sometimes get confused on what happens now. This f of 1 plus h, every occurrence of an x in this expression gets replaced with a 1 plus h. Okay, so I'm gonna just focus on this algebra here, and we're gonna do this algebra out. So this is equal to, so it's gonna be 1 plus h squared plus 1 plus h. Okay, all of that was just f of 1 plus h. I do need to find f of 1. Okay, f of 1 is just 2, right? 1 squared plus 1 is 2. Okay, so minus 2. Okay, all that's divided by h. Now we need this h to cancel, right? I can't plug 0 in. It will cancel. I got to do a little bit of algebra here. So I'm going to go off to the side here. The algebra to be done really is squaring that 1 plus h. So in case you need a refresher. Okay, that gives you 1. That's h squared. So 1 plus h squared can be replaced with 1 plus 2 h's plus h squared. So this becomes 1 plus 2h plus h squared plus 1 plus h minus 2. All that's being divided by h. And now let's see what happens. I have this 1 and this 1 cancel with this negative 2. I do have 2 h's here and another h there, so that's 3 h's. So I have 3h, and then I have this h squared. Now to get the h to cancel, I got to factor an h out of the top. And now those go away. So all that algebra lets me re-express this as 3 plus h. Okay, so back here, I say this is equal to the limit as h goes to 0 of 3 plus h, and I can now just substitute, and I get the 3 that I knew I was going to get. Okay, I believe we did this problem too. I think we got a 5, right? Above, we get 5. We're going to get 5 again using our new definition. Okay, so this time I'm finding f prime of 6 using our h definition. Okay, so I'm going to kind of like half write it. This is f of a plus h is 6 plus h. Okay, so what is this? Okay, let's do the algebra out. Every occurrence of an x gets replaced with a 6 plus h. So this becomes 6 plus h quantity squared minus 7 times the quantity 6 plus h plus 2. Okay, all of this is just what I have in yellow there. And then minus f of 6. So what was f of 6? I think we did it above, but so that's 6 squared minus 42 plus 2 is negative 4. Minus negative 4. All right, we got to get this h to cancel. We got to do some algebra, mainly that 6 plus h squared. So again, so as long as you can do that reliably. Okay, so 6 plus h squared is equal to 36 plus 12h plus h squared. Let's move horizontally more. Okay, so this becomes 36 plus 12h plus h squared. This distributes minus 42 minus 7h, and that becomes plus 4. Okay, now this will all clean up nicely and you'll be able to factor out an h and divide. So notice something that becomes predictable. This 36 and oops, sorry, this is a 4, right? I mean, this is a 6 because I have 2. We should collect that. So that's 2 minus negative 4, it's 6. Notice this 36 and this 6 make a 42, which cancels with that 42. Okay, something like that will always happen because we need this h to cancel, which means it should factor out, and it will. This 12h can combine with that minus 7h to give us a 5h, and I still have an h squared. So I have 5h plus h squared divided by h, and h can factor out. Okay, and now I have 5 plus h. So all this can be rewritten as the limit as h goes to 0 of 5 plus h, which is 5, and we knew that was going to happen. Now, no one's claiming this is like a fun activity. It's not, and in fact, we quickly seek other ways of doing this. For example, if this was an x squared minus 7x, well, it was like x to the 10th minus 7x, right? We don't want to sit here and do x, 6 plus h to the 10th. So it's not like we're doing this for long, but we should just appreciate that it's working. And all we learned about limits help us arrive at this conclusion that the slope of the tangent line at x equals 6 is apparently 5. And we can now, so long as we're willing to hang in there with the algebra, we can find those slopes. So that's the second definition. And again, you want to be able to use both and recognize the structure of both.